Archimedes History. Archimedes was born around 287 BC in the city of Syracuse, which was a Greek colony in Sicily, now part of Italy. He belonged to an influential family and received a well-rounded education in mathematics, physics, engineering, and philosophy. Archimedes studied under the mathematician Euclid in Alexandria, Egypt, where he honed his mathematical skills and developed a deep understanding of geometry. He made significant contributions to mathematics, particularly in the fields of geometry, calculus, and number theory. Archimedes is famous for discovering the principles of buoyancy and developing the concept of specific gravity. One of his most notable achievements was the development of the Archimedes screw, a device used to lift water and transfer it to higher ground. He also invented various mechanical devices, such as compound pulleys and war machines, including the famous Archimedes Claw used for defending Syracuse against Roman attacks. Archimedes developed the method of exhaustion, a precursor to integral calculus, which he used to calculate the areas and volumes of irregular shapes. He formulated mathematical theories and principles that laid the foundation for modern science and engineering. Archimedes is credited with the discovery of the laws of levers, which states that with the right balance, a small force can move a much larger object. He made significant contributions to the study of mirrors and optics, including the development of the burning mirror or Archimedes mirror, a device capable of concentrating sunlight to ignite enemy ships. During the Roman conquest of Syracuse in the Second Punic War, Archimedes continued to work on mathematical problems, reportedly stating, "Do not disturb my circles," when a Roman soldier approached him, leading to his unfortunate death. Archimedes' works were highly influential and revered by scholars of the time. Many of his original texts, however, were lost over the centuries, with only a few surviving manuscripts and references to his work in other texts. Archimedes' mathematical discoveries and inventions had a lasting impact on subsequent generations of scientists, engineers, and mathematicians, influencing the development of fields such as calculus, hydrostatics, and mechanics. Archimedes is often referred to as the father of mathematics and one of the greatest mathematicians of antiquity. He developed a method for approximating the value of pi and calculated it to be between 3,1408 and 3.1429, which was remarkably accurate for his time. Archimedes is known for his work on the measurement of circles, spheres, and cylinders, including the famous formula for the area of a circle, a pi r2. He formulated the principle of the lever, stating that "Give me a place to stand, and I will move the earth." This principle demonstrated the concept of mechanical advantage. Archimedes developed the concept of centers of gravity and introduced the idea of the center of mass, which he applied to various objects and shapes. He discovered and proved several mathematical theorems, including the law of the lever, the law of the equilibrium of planes, and the method of exhaustion. Archimedes contributed to the field of hydrostatics and is credited with formulating the principles of buoyancy, known as Archimedes' principle. He derived a formula for the volume of a sphere and proved that the volume is 2/3 that of a circumscribed cylinder. Archimedes made significant advances in understanding the properties of conic sections, such as ellipses, parabolas, and hyperbolas. He constructed sophisticated war machines and devices to defend Syracuse, including the Claw of Archimedes, which was a mechanical crane-like device used to capture and destroy enemy ships. Archimedes wrote several treatises, including on the sphere and the cylinder, measurement of a circle, the sand reckoner, and on floating bodies. His works had a profound impact on later mathematicians and scientists, such as Isaac Newton and Galileo Galilei, who built upon his principles and theories. Archimedes' contributions to mathematics, physics, and engineering revolutionized the understanding of the natural world and laid the groundwork for many scientific advancements that followed. Archimedes developed a method known as the Archimedes cattle problem for approximating large numbers. This method involved expressing numbers in terms of smaller units. He studied the properties of spirals and developed what is known as the Archimedean spiral, which has a constant growth rate. Archimedes is credited with inventing a system of pulleys and gears known as the Archimedes principle, which was used to move heavy objects. He made advancements in the field of astronomy and proposed a heliocentric model of the solar system, in which he suggested that the Earth revolves around the Sun. Archimedes contributed to the understanding of mechanics and the principles of equilibrium, including the study of forces and the concept of the center of gravity. He developed methods for calculating the areas and volumes of various geometric shapes, such as triangles, spheres, and cones. Archimedes is said to have developed a method for determining the density of objects by comparing their weights in air and water, known as the Archimedes principle of density. He was known for his remarkable problem-solving skills and ability to find innovative solutions to complex mathematical and engineering challenges. Archimedes is believed to have invented a device called the water screw, which was a mechanism used to pump water from lower levels to higher levels. He formulated the law of the lever, stating that magnitudes are in equilibrium at distances reciprocally proportional to their weights. Archimedes contributed to the understanding of geometric shapes and their properties, including the measurement of angles and the calculation of areas and volumes. He made advancements in the field of calculus and introduced the concept of exhaustion as a method for calculating areas and volumes of irregular shapes. Archimedes' works and discoveries were not widely known during his lifetime but were later preserved and transmitted by other scholars, such as the Byzantine mathematician and historian Proclus. These additional points further highlight the accomplishments and contributions of Archimedes in various fields of mathematics, physics, engineering, and astronomy.